This is a series about mixing variable types with regression, mixing categorical and quantitative variables. And in the previous video, I introduced the concept of analysis of covariance, or ANCOVA. Now we're going to continue with analyzing our data. We're looking at differences in different racial groups in terms of income of these groups. And in the last video, we ignored the fact that our variable has, or rather our data set has a variable in it that is education level that is probably related to income. An obvious extraneous variable is level of education, which is certainly going to be related to income. Another potential extraneous variable would be years of experience, how long someone's been on the job, but that's not in the data set. Years of education and income are both quantitative variables, so we can obtain a scatter plot and a simple correlation coefficient to see if they're related. I suspect they are even before starting. Let's go ahead and look. And indeed, it looks like we do have a relationship of years of education to income. We certainly have a relationship, at least in our sample of data. I could see these points as trending upward as we go left to right with years of education. And that's what I would expect to see, that as the number of years of education increases, the potential income level is going to increase. Let's go ahead and measure that with a descriptive statistic, namely the correlation coefficient, and that is 0.65. So a pretty strong correlation, at least moderate to strong correlation that we have here between years of education and income. And since the years of education are in our data set, could we leverage that in some way in our analysis of differences in income for the different groups? So indeed, education and income is highly correlated, no surprise. If we can account for education when looking at racial income disparities, that can lead to one of two possible outcomes, two valuable outcomes. Suppose there's little education difference among our three groups. Well, if there's little education difference among our three groups, then you would not expect it to be making a difference in terms of what kind of income you have in the three groups. Imagine that everyone in each of the three groups, the range of education and the quartiles of education and basically the distribution of education, imagine it was the same for blacks, Hispanics, and whites in our sample. Well, then you couldn't say that any differences that you're seeing in income disparities is due to differences in education. So would there be any sense in including education in the study? The answer is yes. Because if there's little education difference among the three groups, we can actually obtain more power for making inferences by comparing residuals after removing education. Now you might wonder, why is that? Why would looking at residuals after removing education lead to more power? Well, think about it. If education's related to income, then it's a possible explanation, or not only possible, it is an explanation of income level. And if you can remove the effect of education, you're actually decreasing the residuals in your study, right? Because if education is just ignored, but it happens to be a extraneous variable, something that's influencing income, and you're ignoring it, that residual stays in there. But if you pull it out, if you pull education out of income, then what you're leaving behind is a smaller residual, and smaller residuals mean more power. So that's the first advantage that we have. The second advantage of ANCOVA is if there are education differences among our groups, we can determine if there are racial income disparities even after accounting for education. In either case, we're adjusting for education and then looking for income differences. And we call this analysis of covariance because the education variable here is a covariate, and we're removing that residual when we're looking at analysis of variance. So when we're looking at the relationship of the racial groups to income. Now we have to tread very carefully because certain types of education differences can lead to misleading conclusions. And I will talk about that later on because it's indeed the case that many of the ANCOVAs that I've seen in my experience are done incorrectly and reach potentially wrong conclusions. Sometimes they could reach conclusions that are the opposite of the ones they should be reaching because of the way that they're treating the covariate. So the easiest situation, the one in which you don't have to worry about it, is when you make sure that the distributions of your covariate are the same for all your groups. But if you're wanting to look at there being differences among the groups after removing the effects of education because you think that might be influencing or creating those differences, then you can do that, but you have to do it with care. Now, if you think about our particular example here, the question becomes, okay, we saw when we did the one-way ANOVA, when we did the one-factor analysis ignoring education, we saw that there were differences, quite substantial differences. But now the question becomes, are those maybe due to education? Maybe if we look at the differences in the different racial categories with income after taking into account education, maybe those differences will disappear or become smaller or maybe even more pronounced. So that becomes a question here. So let's go ahead and look at the box plot to look at see if there are education differences with the different racial groups. And indeed, I see that there are. I see that the education difference between black and white is not very pronounced, although there is a higher median of education for those in the white group than there is for those in the black group in our sample here. But I also note that for the Hispanic group, it's a much smaller range, especially the interquartile range. So there are differences here. Again, the best case scenario would be to look at these box plots and see them look identical, because then we really wouldn't have to worry about doing anything other than obtaining more power for our look at racial categories and their relationship to income. But since I do have differences here, now I have this other question, and that is, if I control for those differences in education, will I still see differences in income? So let's look at the descriptive statistics for education. In terms of the means, not too bad. We have approximately 12 years for Hispanic, approximately 12 years for black, approximately 13 years for white is the mean education level. If I look at the maximums, I see that the black and the white go much higher than the Hispanic, 3 to 4 years higher than they do. Similarly, if I look at third quartiles, we're about 3 to 4 years higher for the third quartile. So there are those differences, but most of the statistics, especially the means, are reasonably close, and that's a good thing. The closer, the better for this type of study. Now, I'm going to plot the relationship of income to education again, but this time, let's separate the points by race. And so here I have something in which the way the point looks is going to actually be a function of race. The color is actually going to be a function. So I'm actually separating out the points by two types, by color as well as the style of the point. And then down here, I put the similar things in for color and for the style of the point into my legend. So let's see what it does. You'll see what I mean here. So notice that for black, I have a black color and circles. For Hispanic, I have a red color and I have triangles. And for white, I have a green color and I have plus signs. So this is the same scatter plot that we looked at right back here, except here we ignored the categorical variable. We ignored the different classifications. Down here, I'm making it so that I can actually look at these. Okay, so I made the statement that we have to be careful in looking at controlling for education, for looking at differences in income with race. We have to be careful about adjusting, quote unquote, adjusting for education. This is not a design adjustment. This is a statistical adjustment. The best kind of adjustments are design adjustments. Actually, they're not adjustments. They're just randomizing so you remove systematic bias. But that's not the case here. In fact, you could not randomize in this study, could you? You could not randomize to different categorical levels of the factor race. And you cannot randomize years of education that individuals have. So this is necessarily going to be an observational study. So if I could randomize and take advantage of a covariate, that's the best of all worlds, because then you're removing systematic bias, but you're also removing the effects of an extraneous variable. But here, what I have is an observational and a necessarily observational study. As I look at this, the thing that really concerns me the most is that I have all these values out here beyond 16 years of education, in which I have almost all white, one black, and no Hispanic. Why does that concern me? Well, if I'm going to be adjusting for education level, I'm going to be adjusting across this whole range. And what am I doing with the black and the Hispanic in particular? That is, I am taking and extrapolating whatever relationship I find between years of education and income here for Hispanic. I'm extrapolating that beyond 16 years because there are no data points out there beyond 16 years for Hispanics. And similarly for those in the black category, I'm extrapolating for the most part beyond 16 years because I only have one value here, one value. And that value actually looks a little unusual compared to the trend. If you focus only on the black circles here, there's an upward trend with education, and then you get one value down here that's down low, even though it's one of the higher educational levels in our data set. So the fact that we're extrapolating is why we're going to have to take this with care. What I'd rather see is a whole lot of overlap of all three of these categories along the whole range of the data. And I don't have that there. And because I don't have that there, then I'm going to have to take into account or maybe check to make sure that it's okay for me to continue with this analysis. So I'm going to stop right at this point because what we're getting ready to do is we're getting ready to do some ANCOVA in which we're going to make some assumptions. That is, we're going to have some conditions that are necessary not only for valid inference, but for valid statements. We're going to have to know that we have met conditions in order to use ANCOVA and make valid statements. And that's where I'll pick up in the next video.